Howdy. Give me a few minutes, I'll turn on the audio. Hi everyone, welcome. Hopefully you guys can see and hear me okay. Hey Astro, I'm not sure how to pronounce that. But hello, how are you doing today? Let me go ahead and put up a poll. Let's see. Just wondering if you've tried the new version of AstroSharp yet. Go ahead, start the poll. See what everybody says. Okay, so what I've got here is basically kind of like what I've been working on to try and get the PSF sharpening for the stars be different than the PSF for the sharpening for the rest of the nebula. Yeah, good. It's going well. I think it's okay. Still trying to work out some different things. And I'll go ahead and show you some of those developments here. So let's see. Yes, no. So about 2/3 haven't tried the new version of AstroSharp, which is fine. So yeah, so the development is good. Can you guys hear me okay? Do I have the audio on? Hopefully I do. Audio is on, don't worry. Good, thanks. I'm waiting for the kids to fall asleep, and then I'll have some time. Let's see. Yeah, kids kids falling asleep is always fun. Fresh data to try it on. Cool. That's awesome. Okay, so what I've got here is an image of, maybe I'll just do the full preview. It's an HA image that I took with like a Canon lens of the Heart and Soul Nebula here. It's not a very good image. Like, it's just like a stock Canon lens. And so I just thought it would be a good test. I'm also trying to process some images as we speak. So a couple months ago, I did a live stream of a galaxy cluster, and I haven't processed those data yet. So I got a lot of like 30-second images. So I kind of want to process that. If I can get it to work, then we might do that on stream too. So okay, so let's see here. So we've got the Heart and Soul Nebula taken with a Canon stock lens, and like sort of like a zoom lens, but it's made for like EFS sensors, and so it's like I've got an adapter that I can fit it onto my ZWO 294mm Pro, and I thought I would just try it out because I can get kind of wide field images, and I can also, zoom in if I want to. But I found that if I didn't stop it down like a lot, then I would get really bad stars, and I still kind of get like these really misshapen stars everywhere. You can kind of go around the preview and see that nowhere in the image are the stars a good shape. So I don't expect AstroSharp to fix the stars, but I mean, I thought I would test it, and we can see how well it works on different types of data, like from data from a Canon lens that's not very good. And so what I'm going to do is, so what I have here is like a star mask, and I'll just show you. So when I update the sliders, it should give us a good preview of a star mask. So here we have all the stars. And then this is what we want to do to control the blending between the two different models. So I don't know if anybody catch the last stream. But with the last stream, I kind of showed this off. But I've done a little bit more. So I've added a little bit more functionality to it. So you can see like a fixed star mask. Sometimes like the star mask just doesn't work. So this little thing helps you fix it. So you just move it up like one by one until like you get you get stars. So I mean, once you get past a certain number, like it's fine. So in this case, it's just 1. Hope this makes sense. So what we have here is it's detecting the stars pretty well. It's saying, okay, this is where it thinks the stars should be. And here's the star sensitivity. So if like we want to detect more stars, we could decrease the sensitivity. Nope, we don't want to download it. We just want to update the sliders. And I think I'm going to rearrange all of these sliders at some point, so it's a little bit more intuitive layout. Maybe switch the download and update sliders buttons, but we'll see. And so you can see if we decrease this number, we're going to get more stars, but we're also going to get a lot more like false positives. And so you'll see that here. So we've got a whole bunch of stars here, but like I'm sure half of these aren't good enough that like we would actually consider them stars. They're just kind of local maximum, and it's being too sensitive. So I think probably a good number here is like 98 or 99% as a default, and I think that's pretty good. So like we have 99% star sensitivity, so it's very sort of like conservative on when it thinks it's a stars. If we could go up here to 99.9 if we wanted to. And again, you would see the stars, even fewer stars. But let's keep it at like 98. I think 98 is probably good. Yeah, that looks good. So, I mean, you can just kind of pan around the image to make sure like stars are being detected. Seems like they are. Okay. So we've got the stars detected, and I think what we want to do now is blend the stars. So this is what these two blending things are. And I think we kind of like, this shows the histogram of the star mask right now. So we can use this histogram to kind of figure out things. And I think what the histogram is telling us is there's a lot of dark. So that makes sense. There's a lot of black here. And there's a little bit of white up here. I don't know if you can see this, but there's like just a little bump here showing us where the stars are. And that's because everything is either 0 or 1 at this point. And so we can change this. But first, I think we want to do some feathering around the stars, so we can like feather the stars a little bit. So maybe to like apply a Gaussian blur, and this 3 would be like the kernel size for the Gaussian blur. So if we update the sliders, you'll see that like everything is blurred out, but we can fix that. So if we change this to like 100, Maybe not this one, maybe this one. Yeah, the bottom one probably. Yeah, we changed this one to 100. Then like the stars come back, and then you can see it's kind of blended in a little bit. And so these blending numbers just kind of tell AstroSharp, okay, where do we want like the 100% star PSF model to be? So the brighter it is, the more the PSF model for the stars will be applied, and the darker it is, the more the PSF model for the nebula will be applied. So hope this is all making sense. So like right here, this would be all like star PSF model that will apply to the image, whereas in the black it'll be mostly nebula PSF, and that's of course these two sliders here. So the 70% of PSF and this is the nebula, and the PSF for the stars is of course for the stars. And so what we want to do is kind of get like a good blend to where like the two models kind of blend nicely together. Otherwise, you can get kind of artifacts and ringing and stuff. And feel free to like ask me questions as I'm explaining this. It's like it's fine. I don't mind. Okay, so if we wanted to, we could like decrease. So we could decrease this number and increase this number to like move this stretch more to the left. So if we put out in a 1 here, we could update the sliders, and suddenly you see sort of everything is pretty stretched. So anything, you know, that is even very faint based on this feathering is brightened up a lot, and we kind of want that. Otherwise, we wouldn't get any good mixing. But so the blending here kind of like controls that. This first blend determines how far right the curve starts at, and the second sort of blending number determines how far left the curve kind of starts at, and they kind of compete. And I'll show you what that means. So if we had like just 1 and 1, we update the sliders, then it's going to be in the middle. It's just going to be a straight sort of linear transformation of the data. But like if we increase this first slider, we're going to get a bend that is more to the right, and it's going to be a more of a sort of, I would say like an acceleration type curve, you know? So I'll show you what that is. So again, see like we get a bend at the right, and it's sort of like acceleration, you know, like it almost like or like a parabolic, like a positive parabolic transformation or something. It's not quite that, right? But we get that bend that curves upwards. Whereas this blend 2 1, so let's reverse that. Let's make this 110. It's kind of the opposite. Now it's going to be on the left, and we kind of get like this deceleration type curve. And so what we want to do is have good blending. And I think a good general kind of rule of thumb that I've had kind of success with so far is having a high blend 2 and a low blend 1. And so that applies to the star mask. Now, all of these numbers only apply to the star mask. If we switch it back to like the dual PSF model here, and we update the sliders, this isn't going to affect any stretching or anything for the image itself. It's just going to affect the mixing based on the sliders. Okay, so here we have like a PSF of 3 applied, and we can see it's kind of really sharp. It's pretty like there's maybe some ringing around the stars. So if we wanted to, we could decrease this slider maybe to like 1.25, update the sliders, and it'll create the star mask based on these parameters. And we see that the stars are now not quite as sharpened, right? But we still get the sharpening in the nebula. Now, when we change it to the like dual PSF model, this histogram no longer is the star mask. It's now the actual histogram of the image itself. But the red line still shows you the stretch of the star mask. So it's kind of like, I don't know. I don't know if it's the best. I don't know if I'll keep this in here, but I use it for like development because it helped me in like developing and troubleshooting stuff. So you can see like the stars now are not sharpened as much, and there's like not as much ringing. So if we wanted to, we could increase the sharpening of the stars, and they'll become really super ugly because of that. And you'll see a whole bunch of ringing and horrible artifacts. There we go, right? So again, the PSF really kind of like affects the stars mostly and doesn't affect the nebulosity as much. Now we could move this top slider up, and then everything would be kind of sharpened, and it would be look just probably too really bad. Yeah, so everything is sharpened. The nebula is sharpened too much. The stars are sharpened too much. And so you can see the differences. I don't know if this make any sense. Again, please, like, I know there are people watching, so if you have any questions, just let me know. I don't mind answering them. Okay, so I'm going to move this down. Well, move this one down back to here. So what you can do is you can get like really quite aggressive sharpening of the nebula or deep sky object that you're looking at, while hopefully controlling the stars. And if you see like things aren't blending very well, then you can change these sliders. So let's say like let's just change the sliders just for the heck of it, right? So I mean, not the sliders, but these blending parameters. We update the sliders, and you'll see that like the blending just isn't very good. Yeah. So again, so we've got just you know the PSF of the nebula that we used is seeping into the stars quite a bit because we're just not blending things very well. I'm going to move this back up, and so the key is to try and get this slider or these parameters. I keep calling it sliders. It's late. I'm sorry. I've been working a little bit today. So the key is to get these sliders in a good enough spot where like the nebula and the stars blend together nicely, and you don't get like the PSF of the stars bleeding out too much into the nebula, because then you won't get any sharpening of the nebula. So we can kind of scroll around and see what's happening. Yeah, like the stars look okay, right? Like we've sharpened them a little bit. I don't know if there's a difference, but you can see that like the background is sharpened a lot, because we have this high PSF slider. I don't know if I would keep it at this high. Like I think something like keeping them reasonably close, like if the PSF for the stars is 1.5, then probably a good idea is just to like sharpen it just a little bit more for the nebula. But generally, I think, right, like even when you sharpen things in GIMP or in Photoshop, you've probably ran into the problem that like you can sharpen a starless image quite a bit and get some good detail out of it. But like if the stars are in the image, then things kind of get funky. And it's the same thing with AstroSharp. I mean, I don't think AstroSharp is it's definitely not a deconvolution tool, right? Like I trained it on different point spread functions, but I didn't make it deconvolve things. I don't know what it's doing underneath the hood. And so it's a sharpening tool, right? But it hopefully it does an okay job. So yeah, I mean, I think the stars, like if we had this at 3.5, if this was just, if there is no PSF slider for the stars and we did everything at 3.5, stars are just gonna not look very good. And a lot of people have complained about that. Yeah, you can see like that they've brightened up quite a bit. There's little halos around them. And so I'm kind of excited about this PSF slider thing functionality. And I think I've got it in a kind of a good spot. I don't know what you all think. Should we process this whole image, or do you think we should do some processing of some galaxies in GIMP and Cyril? So as I've been speaking, like I've been stacking some images too. So let's see, process an image. Sure. Yep. Good. Let's do that. I'm not opposed. Okay, so as I've been speaking, I've been stacking some images of like just a whole bunch of like galaxy, like a little galaxy cluster. So I think the center here is NGC 6045, and I did a live stream probably back in June. And I just never got around to processing the images. So I've got the L here. So I might as well do the LRGB compositing right away. So I'm just going to go to, sorry, you guys probably want to see it. So I'm going to go to RGB compositing, and then here I'm going to put in my luminous layer, my RGB layers, and we'll see how that looks. Okay. And of course, because I stacked it in Cyril, everything should be aligned. So it should work. Should work pretty well. Okay, so I've got all the images here. So you can see that it's like a cluster of galaxies. I've got the L, R, G, and B. I haven't looked at these data yet, so I'm not sure how well they turned out. And they were like a whole bunch of 30-second subs that I did on stream, so I don't have a ton of data. Let's go ahead and check. Yeah, sometimes this happens. I'm just going to open up the L image then. Let's see here. So, and we'll see how that is. Sometimes it happens, like you get funky results. Oh yeah, got a lot of donuts. Got a lot of donuts. Yeah, that's. I guess I didn't take very good flats. But you can see like the all of the galaxies here. So if I zoom in, we've got a galaxy here, galaxy here, galaxy here, galaxies here. Tons of donuts. Really bad data. Galaxy here. I don't think I could find the right flats. It's been so long ago. I put the wrong flats in, but we'll see what we can do with this. So instead of the auto stretch, let's just go linear. Yes, the dust specks. That's right. I don't know where my flats are that I had for that imaging session. That's the problem. So, and it was taken on a C8, so a Celestron C8. It's not the best. I mean, it's a good scope, but it was old and it's got a lot of dust on it. So let's go ahead and we can try and fix it. So let's go ahead and just do some stretching. So we'll go to generalized hyperbolic stretch. And zoom in, find the left part of the histogram, and zoom back out. Move the stretch intensity up and the stretch factor up. And we won't stretch this as much as the auto stretch, so hopefully the dust specks won't be so bad, but they'll still probably be a big problem. It's one thing that's nice about my refractor. It just doesn't have as many problems with like all the little dust motes and everything. Okay, so I'm stretching it a little bit. I'm going to click apply. Let's see, let me go ahead and move the black point down a little bit. Make sure we're not clipping anything. We're not. Click apply, and then go back to generalized hyperbolic stretch. You go logarithmic scale, and then again, like the symmetry point, of course, is where we want to sorry, increase the contrast. And so, before that, let's see if like the background extraction does anything. So I should probably download the new version of Graxpert with the AI, and maybe it would help. But like, let's just see. Make some sample points around here. I don't think it'll help with the dust motes, but we'll try. Okay. Yeah, it's not going to help with the dust motes at all. So we remove those. So compute. Yeah, it's doing something. Okay, turn auto stretch off. Those are bad dust motes, dust specks. Okay. I need to find the flats. Maybe I'll find the flats one day. So I kind of want to increase the contrast, probably initially where it's like really bendy here. So I'll probably put it there. And then again, stretch it. Okay, looking good. We can see the specks here. And then let's go ahead and click here again. Somewhere around here for the symmetry point. Stretch it. No, never mind. Don't want that. This. Okay. All right. I think that's pretty good. We've got a whole bunch of stuff we have to fix, which we can do that later if we want to. Okay. Let's go ahead and make a starless image. I kind of like the brighter stars in the galaxies, but we'll go to remove the stars. So we'll go to star processing and StarNet star removal. We don't need to pre-stretch it because we already stretched it. We don't want to recompose because I'm just going to put it into GIMP, and I will generate the star mask. Okay, so we got 56% of people have said that they have tried the new version of AstroSharp, which is cool. Okay, so it's running StarNet. We can see the progress bar right here. Once that's done, we'll have 2 more images, and I'll pop it into GIMP. We'll see if we can remove some of those dust specks. Okay, it's finished. So I still have the Eagle Nebula that I processed in the last video. If you haven't seen it, you can check it out. Maybe you've seen it. Okay, so we've got the processed image, the starless image. And without the stars, it's so much easier to like remove these dust motes. So you can use the clone tool if you want to. There is, let's see. I always forget where it is, but like there is here heal selection, which is like a plugin forget what the plugin is called. Resynthesizer plugin, that's it. And so if we just lasso this, and then hopefully it works. Sometimes the plugin doesn't work, and it probably won't because I'm streaming it. But like we just do heel selection, and we just wait for the thing to pop up. We figure out how many pixels around that we want to use for context. And we'll do 50. Usually the default is pretty good. And it'll slowly fill in those pixels. I feel that when I was doing the live stream, there weren't as many speckles on on the image. So I feel like I took better flats, and I just don't know where those are, and I used the wrong flats for this image. Or maybe like I just don't know where the flats are anywhere. Okay, so there it is. That little dust speck is gone. We can do the same thing for the more egregious dust specks. So we do the lasso tool again, lasso this. We hit Control F, and it's just going to repeat the last filter that I did. So again, you can see the resynthesizer plugin doing it in the progress bar here. Yeah, can relate to the flats problem. Yep. I think it's part of the telescope. Just like it's just an old telescope. Like I bought it used. There's just a lot of dust on it. I probably need to clean the optics. Okay, we're gonna try this. Sometimes around the edges it has trouble with stuff. So if it doesn't work, it might crash everything. It looks like it's working, which is nice. All right. Okay. We'll probably just do the most offending ones here. So I think sometimes you can like be kind of cute with it. I don't know if it'll work. Sometimes it'll copy in part of the galaxy, which we don't want. We'll just clone it out. But yeah, I think great shortcut is just Control F, you know, to redo the last filter you applied on something. Yeah, it's kind of weird. A little bit of speckling and stuff. Don't do this one. So we might come back with a clone tool and clone those out. There's so many galaxies in this image. It's amazing. 1, 2, 3, 4. I mean, StarNet might have removed some of them. I don't know. 5, 6, 7, 8, 9, 10. We've got a couple of interacting galaxies. 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4. If I counted right, there's at least 24 in here, which is crazy. Nice little small galaxies. Okay, now I'm going to go ahead and open up the star mask. I don't think I'll bore you with removing all the dust. One day I'll find the correct flats for it. Right. And then we have this. We can use addition if we want to add stars back in. That's layer mode. And I don't know, maybe I stretched the stars a bit too much. They are kind of bright. So you could always, if you want to, go to filter, for example, and just generic and erode and see how that looks. I don't know if it'll look any good, but just like Control F and repeat it. I don't know if it's doing much. Just going around here. Check and see. Oops. Yeah, it doesn't seem to be doing much. So sometimes it works, sometimes it doesn't. Maybe I need to like make a selection. Yeah, it's another chain. So the center, this galaxy right here, I'm gonna circle it here, is NGC, I think it's 6045. Let me double check that for you. So NGC 6045, yeah. And right around, so I took this with a Celestron C8 at the native focal length of 2000 whatever millimeters. So it's pretty far in a ZWO 294mm camera. So we're zoomed in pretty far. And there's just a ton of galaxies here. One time I did like the Coma cluster. Coma cluster is pretty cool, but I did it with a RC. Again, and I didn't have the RC collimated very well. And so it just, I don't know. But I mean, we've got problems with flats, which is ruining the image. So maybe what we can do is we can darken up the background, and that might help it some. Oh, guess I want to select all, right? That would be a good idea. Instead of just that one galaxy. We darken up things a little bit. I don't know, it might make things look worse. I don't know. Hide the bad flats. I don't know if that helps. Let's see if the problem is like you can still see it. It's just so bad. So I don't know which looks better. It almost looks better when it's brighter, to be honest. From what I can see, I don't know what you can see on YouTube. I don't know how much compression is happening on YouTube, but like, I just don't think I'm going to get rid of those flats unless somehow like Graxpert can just make things better. Okay, so we've got the L processed. Let's go in and do the RGB compositing again in Serial. And this time we'll remove luminance and see if that helps. Okay, let me go ahead and put in just the RGB. Give me 1 second. I mean, if it's not like tracking errors, it's like flats. So. Okay, I've got the R, the G, and the B in here. We'll see how things look. See if it does a better auto stretch. Okay, we've got a lot of green. Don't like the green, so let's finalize the color balance. Selecting area of the background, use current selection, background neutralization. It does a good job. Okay. All right. Yeah, we've got a huge something or other going here. Some donuts here. It's not quite as bad as the luminance. So I don't know what's going on with that. We've got some artifacts from the ZW and bin 2x2 mode. So that's just from just amp glow or whatever you call it. So let's go ahead and do the background extraction. We'll see what happens. You're making that see it work hard. Yep. I am. So yeah, thank you. Yeah, the C8 is working hard. It's an old scope. I bought it used, so it's pretty old. Oh, I should probably crop this first. Let me close this and crop it. I should have done it for the luminance too sometimes, but what can you do? Okay, I'm going to go ahead and click some points around here. Let's compute the background. Let's move that all the way up first. We'll see. Add some dither. And one more time. Yeah, it's better. It's better. Okay, so let's go to, we do the arcsine transformation first, or whatever this is called, and just stretch it first, just so we can get some better star color. Might have to remove some of the green noise out of here. 2. And now we'll do the generalized hyperbolic stretch. Checking to make sure everything is aligned correctly. Set my symmetry point there, and then start stretching things. And with this one, I don't think we want quite as an aggressive stretch as the previous one. I don't think we have to stretch this one. Oops. Quite as much anyway, because the galaxies are pretty, like, the light from them is pretty concentrated, so it's not like you have to like stretch out things that much to bring out nebulosity and stuff like that. So okay. Maybe one more time with this. You can see like huge curve here, so maybe we'll set the symmetry point somewhere around here. Oh, sorry. Would help to change it back to generalized hyperbolic stretch. Set the symmetry point somewhere here, and then we can start stretching a little bit. Okay. I've seen some people take this and like stretch it as much as they want to, like do crazy stretches, and then change the symmetry point, later. I think that could work too, but I think that's fine for what we need right now. We've got like the color information there, so I'm going to go and again, we're going to like remove the stars just so we can, because we can. And then just execute. So what has everybody been imaging? Anything? It's been cloudy where I've been at, so I haven't been imaging much of anything lately. So, okay, it's ready. Okay, so again, we've got a problem here is that we crop that image. And so things aren't going to be lined up, but I would just go ahead and open things as layers. Anyway, actually first, because I opened the L channel, like luminance first, we need to change the color mode to RGB. And then we can open the RGB starless layer and everything. So let's see here. So it's the compositing result. We have the star mask and the starless. So we'll open those as layers. We'll just make sure that image composing is set to not none. So whatever this is, and then it should open as layers, and we will start aligning things. This to the top, deselect the starless layer, and then change the star mask layer to addition. And again, this is the same process I did in my last tutorial. So you should see like a whole bunch of duplicated stars. You can see like we zoom in, like this here is the same star as this star. So all I have to do is just press the M key to move, select the layer, and then use the arrow keys to like bring it over. And I think I probably have stretched the stars of the luminance too much, but that's okay. I can do it later, change it later. Okay, we just kind of pan around, make sure that the stars are in the correct spots. Let's see, like I think that's correct. The problem is like stars aren't perfectly symmetrical. I mean, they're not perfectly, circles. So let's remove this one. I mean, I think seems correct. Let's go ahead and change the opacity of this one. Yeah, I think it's fine. I hope. Okay, so we've got the stars aligned. So I'm going to go ahead and change this to normal. And then what I want to do now is take the starless image and align it, the starless color image, and align it to the star mask color that we had just aligned with the others. Hey, James, how are you? Oh, yeah, meetings. I understand how that is. But a lot of meetings to go through, but thanks for stopping by and saying hi. I appreciate it. Okay, so I'm going to go ahead and align this layer here to this layer here. So let's go ahead and do that just with the arrow buttons because it's so easy. And there we go. We're aligned on one side. Now all I have to do is line it, go left. Oops. Don't know what I'm pressing. Okay. There we go. Okay, so everything should be aligned, I think. And we can double check. So make this normal. Everything's normal. So, oh, it's not aligned. Not aligned at all. What did I do wrong? Did I go the wrong direction? I must have gone the wrong direction. Okay, so let's go ahead and go back here. Always double check. Measure twice, cut once, right? Okay. Oops. Okay, so press the M key. Move it here. Yeah, there we go. Use the arrow keys. Oops. Okay. All right. Hopefully that's aligned now. Okay, the stars are aligned. Here's a galaxy. The galaxies are aligned good. Okay. So with this image, we might just want to use the color stars because they're already smaller than the L stars anyway. So you can see how that works if we just use addition here. Yeah, I think that's fine. Keeps the stars a little bit, makes them a little bit smaller. Okay, and now what we have to do is take this color, and I like the LCH color mode. I think it is generally pretty good. And then let's go ahead and crop this image. So I'm going to press the rectangle, the R button for rectangle select, and then select all of this stuff and crop it. So image, crop to selection. Give it a second. Ooh. Hopefully I'll find the flats and I can actually make a decent image of this. So we've got that. We can move this. Let's darken up the background, I guess. Probably look better. Maybe. Click OK. That's a messy image. That is really bad. But it is what it is. Not much we can do about it right now. I mean, I guess I could restack it and try and find the flats, but I'm not going to do that on stream. Okay. If we want to, we could increase the saturation of this level. So we could either use curves or saturation or whatever. So if we use saturation, like you can overdo it quite easily. I think somewhere around here is good. And then to get rid of the star noise in the background, there's a couple of things you could do. You could either, well, you could do both if you want to. You can go ahead and do a Gaussian blur on the color part. So again, we're using the color layer and just kind of do a little Gaussian blur, and you can see the difference. If I put split view, you can see there's a lot of color noise here compared to that. But it's still kind of blotchy, and you do lose a little bit of the saturation of everything. Like, but I think it's okay. Let me just pan around. Like, it's going to take a lot of processing to get those donuts out. So something that just happens sometimes. So I'm not, I'm not worried. I think everybody has had donuts in their images pretty bad. Okay, so I'm going to go ahead and flatten this, and well, before I do that, let's go ahead and make add a layer mask. We'll make it full transparency, so like there's no color coming through. So you see everything should be black and white. And then we'll take this layer and copy it and then paste it into this color, into this, layer mask. So we pasted it and we'll go to anchor layer, and now it's in here. So we can press Alt and then we can just see the layer mask itself if we want to. We disable it with Control if we want to click on it. And so if we disable it, you can see all this background color. Hopefully this shows up on YouTube, but all of this background color comes back into it without the star mask. So let's go ahead and enable the star mask again, and you can see it's gone. Okay, and so we've still got the color in the stars. We've still got some good color in the galaxies, but like these galaxies have lost a little bit of color. So we can go ahead and, with this layer mask selected, we can go ahead and just brighten up the midtones if we want to add the color back into those fainter galaxies. Got to be careful though, because like as you do it, you can also sort of increase the color noise in the background as well. So you can just kind of use the sliders to stretch things if you want to. We can go ahead and make this visible, and you can see what it's doing. So yeah, things are pretty. There we go. Darken up the background. And then there, we should still have a little bit of color in the galaxies. I don't know if you can see it too much. Still got the color in the stars. And yeah. Okay, this little blotchy stuff is going to bug me, but I don't think this is going to be my final image anyway. Like I'm going to go back and redo this. Hopefully I can find the correct flats to do it. But let's go ahead and flatten this. And I think we'll just put it into Astro Clean after we darken up the background just a little bit more. We'll see if we can get any sort of noise, remove some of the noise out of it. So we're going to export this as a TIFF file. I'm going to call this a bad image, bad image, because it's pretty bad. I mean, it's got a lot of cool galaxies in it, but so many donuts. Okay, I'm going to go ahead and open it up. Oh, before I open it up, every time you open up a new image, go ahead and make sure it's preview, so it doesn't like try to process the whole image before you've chosen the parameters that you want. So I'm going to open up the bad TIFF file. Because that's a bad, just a bad image. Okay, so we got the bad TIFF file open. Let's see its color. Wait for it to process a little bit. Okay, we want Astro Clean because I don't think I want to sharpen this image very much. Anyway, and then we'll see what happens. So right now the aggressiveness slider is at 1, so it's going to do quite a bit of denoising. That's a lot of denoising. So you just scroll around the image a little bit. We find some galaxies and see how it's affecting the galaxies. I know that there's those galaxies in the center. NGC 6045 is right in the center. Here it is. I'm pretty sure it is. It should be somewhere in the center. Okay, so this is one of the galaxies. Do we want it at 100%? I don't think so. Let's go ahead and do just 50%. Yeah, it's fine. Do a full image, and we'll see what happens. We've got 50% who say they have used the new version of AstroSharp and 50% who haven't. You guys should use it. I mean, you don't have to, but put a shameless plug on that it's here. So it's there if you guys want to look at it. And then once this is done processing, we'll take a look at how well it cleaned the image and probably end the stream. Yeah, it's going to take a while. I should have put it on multi-core. It would have read it twice as fast. So those of you who are still here, have you been imaging anything at all? Maybe I'll make that a poll. Yeah, go ahead and make that a poll. So have you imaged anything in the past couple of weeks? I have, but I only got one night, and the rest of the nights have been pretty cloudy. It was actually the last stream that I did. So the Wizard Nebula. Cool, Michael. That's really cool. That's a great target. I need to redo that one. I've done that before, but I don't think I was quite in focus. I like the Wizard Nebula a lot. The last one that I did, let me think. There's a lot of nebulosity in the Milky Way. Let's see. First time for me. Cool. Have you just started out? This is like, how long have you been doing astrophotography, I guess, is a question. (2018). Cool. Yeah. Yeah, so pretty experienced. Yeah, there are so many targets out there. And then of course, like, you want to do a target, but when it's up, like there are clouds or just something happens and it can be, you know, things can get in the way. Maybe it's like not the right time. Like you just don't have, I don't know. Like for the longest time, like I love the Trifid Nebula. Like I think it's one of the coolest things, but I could just never get it. It was too low on the horizon and my house was in the way and I could just only get like 30 minutes of data on it at night. I just could never get a good image of it. Using at edge 8-inch. Wow, that's pretty cool. Yeah, those are good scopes. What camera are you using? If you don't mind me asking. Yeah, cool. That's the same camera I got. Like it. Do you usually use bin 2x2 mode, or do you use like just the regular like single binning? I would think that with an edge 8-inch, like bin 2, yeah. Yeah, I feel it helps keep my stars round and not like, drift. I guess with my refractor, like it would be fine in bin 1 mode, but the file sizes just get huge. They get really big. And everything takes longer to process. So I'm happy with bin 2. I did see, sort of going off on a tangent, I did see one user who said that they cleaned their image first and then used like an AstroSharp model on it, which to me seems backwards, but they said they got good results doing it that way. I have to test it out. I just test it out, but like it seems like you would want to do the sharpening first because the noise reduction is going to kind of get rid of some of the detail, and you want as much detail as you can for the sharpening. So I don't know. Just got a 60mm solar scope, which I haven't had a chance to use that. Oh, that's pretty cool. Are you going to use that for the eclipse? Maybe I guess I'm assuming that you'll be able to see the eclipse and that you're in like the US. But maybe I'm making the wrong assumptions. I know we've got the eclipse, I think, on the 12th, right? So the annular eclipse, and then we've got the full eclipse in April. I'll try northern US. Yeah, cool. Yep. What's nice is you can practice a lot with it, right? Right now, before the full eclipse. I know I kind of I want to see it, but of course it's going to be hard, to get to the right place at the right time. Okay, so it's almost there. Here we go. Good. So I'm going to go ahead and download the processed file, and then save it. Just pull out noise reduction, save it as a TIFF, and then open it up. Open up my bad image file. Let's see. Here we go. Okay, we'll see how much noise reduction there is. So this is after, this is with a noise reduction, and this is before. Again, it's 50% noise reduction. It could have gone more, but I think it does an okay job. Stars aren't perfect. I wonder if this is a tail of the galaxy. I have to look at that. It looks like there's like a tail to it or something. But I don't know. Anyway, lots of donuts, bad image. I'll try and find the correct flats, and maybe I'll post a good image of it sometime on YouTube or something. So, all right, I think that's about it for this stream. And thank you all for watching and commenting and voting and everything. So hope everybody has some clear skies and gets to image to the heart's content the next few days. All right. Thanks for watching. Yeah, thank you, Michael. Thank you.